Hi everyone, so this is part of the statistics revision for the exam coming up. So how it's going to work is I'm going to do a question a day from the October 2021 paper, and we're going to work through paper 1 before paper 1, paper 2 before paper 2 and paper 3 before paper 3. Okay, so let's get straight into it. So we're starting with question 1. We have Josh, who works as a proofreader at a company. He's currently correcting the errors in spelling, punctuation and grammar in the text of a new novel. So that's just context. He has to make a record of every change he makes to the text. The author's last novel had 136 pages and needed a lot of corrections. The bar chart in figure 1 shows the distribution of text errors per page in the last novel. So again, that's still setting the scene of the context, but it tells us that figure 1 shows us the number of errors per page. So there was this many that had 0 errors, this many pages that had 1 error, and 20 pages that had 2, and so on. So, assuming that the new novel has a similar distribution of errors to the last model, estimate the probability that a randomly chosen page has fewer than 2 errors. So we're looking for probability and we're looking for fewer than 2 errors. So I'm going to look at my bar for 1 error. So the amount that had 1 error is around 42. And the amount of pages that had 0 error are around 58. And that is the amount that had fewer than 2 errors per page, and my probability will be out of the total number of pages. In this case is 136. So that is 100 over 136. In decimal format, that is 0.735. So either one would be correct. Part 2 of question A says, work out the expected number of errors per page. So in other words, when we see the expected number, what that means is the mean. So to work out the mean number of errors per page, I'm going to use the frequency table method. So if I create a frequency table where I've got X, which is the number of errors per page, so we have 0, 1, 2, and N, which will be the frequency, so how many pages had that number of errors. So 58 pages had 0 errors, 42 pages had 1 error, 20 pages had 2 errors, approximately 8 pages had 3 errors, about 2 pages had 4 errors, about 4 pages had 5 errors, 0 for 6 and 2 for 7. So that is me setting myself up to be able to work out the total of the numbers. So to do that, I'm going to do n times x. And the reason we do that is if we were to write all these numbers out as a list and add them together, we would then divide by 136 to work out what the mean is. So this is a way of doing it as a frequency table, which everyone should be familiar with. So 0 times 58, 0, 42, 40, 24, 8, 20, 0 and 14. And then I'm going to work out the total of my numbers, the sum of my numbers by adding them together, which is 148, and then divide by how many numbers we had. So the expected value of x equals 148 divided by 136, which is 1.09. I'll do it to 3 significant figures, 2 decimal places. Let's move on to part B. So it says the new novel has 223 pages. Assuming that the new novel has a similar distribution of errors to the last novel, estimate the expected number of errors in the new novel. So previously we said that the expected number of errors per page was 1.09. So to work out an estimate for the expected number of errors in the new novel in total, I would do number of errors per page, average number of errors per page, which is 1.09, times by the number of pages, which is 223, which gives me an estimate of 243.07 errors per page, or we could say approximately 243. Part C, it says, give one reason why the assumption used in A and B may be valid. So the assumption used in A and B, we'll just go back to question A and B. So assuming that the new novel has a similar distribution of errors. So we've assumed that the new novel has a similar distribution to the first novel, which had this distribution here. And again here it says assume that the new novel has a similar distribution. So why is it reasonable to assume that the new novel has a similar distribution to the old novel? This is where we have to get our common sense brain on for stats. So this has nothing to do with any of the skills you might have learnt, but this is thinking in context. So the context of this is that we have an author who has written 2 novels. So why might it be reasonable to assume that they have a similar distribution? So it's reasonable because we can assume that because it's the same author who wrote both novels, he'll have the same writing style. So it's likely to have the same number of errors per page, something along those lines. So it's being able to identify the context of the question and to justify the assumptions that we made. And then on the other hand of the argument, it says give one reason why the assumption used in part A and B may not be valid. So in other words, why might the second novel not have the same amount of errors as the first novel? His writing or grammar may have improved since the first novel. Excuse my spelling mistake there. He may have used a spell checker for the second novel, so something that would imply that his writing will have improved, which would therefore mean that there'll be less errors, or there'll be an impact on the number of errors. So that is all 4 parts of that question. In total, we have 8 marks. So that's 8 marks for question 1, and that is being able to find the expected value, find probabilities from a discrete distribution, and also to make those inferences, which we're expected to do in every question. Okay, let me know if there's anything that you'd like me to go through on the next video. I am also doing a topic a week, so I will be posting a video on confidence intervals following this. So please like and subscribe if you found it helpful, and keep an eye out for my future videos. Thank you, and all the best with your revision.